we want to solve this initial value problem given here when the right-hand side is a function that is discontinuous. So this is f of x is given by 1 between 0 and 2, and by negative 1 when x is bigger than 2. So the first thing we want to do, and so this is f of x here. I just wanted us to have an idea of what f of x looks like. It is 1 from 0 to 2, and then negative 1 when x is bigger than 2. So what we want to do is we want to break this into two cases, when x is between 0 and 2, and then when x is bigger than 2. So we'll start with this case. When x is between 0 and 2, I know that f of x is 1. So then the problem I have to solve is dy dx plus y equals 1. This is a linear equation, so we'll go ahead and find the integrating factor, which is e to the integral of 1 dx, or e to the x. Multiplying times it gives me e to the x dy dx plus e to the x y equals e to the x. On the left-hand side, I have y e to the x prime. And on the right-hand side, I keep my e to the x. I can integrate both sides and have y e to the x is equal to e to the x plus c. Let's call that c1, because we'll have another c appear later. Now, I can finally solve for y here. Y is equal to 1 plus c1 e to the minus x, if I multiply by e to the minus x. Now, the initial condition tells me that y of 0 is 1, so if I try that here, y of 0 is equal to 1 plus c1 e to the 0, which is 1, and that needs to be 1. So that c1 here is 0. So then y, and I'm going to write it here, y is equal to 1 in this case. This is when x is between 0 and 2. Now, let's break this into two like this. If I'm thinking of when x is bigger than 2, then I have a different problem. I have dy dx plus y equals negative 1, because when x is bigger than 2, f of x is negative 1. Proceed in the same way. I still have the same integrating factor. You can check that. I'll go ahead and multiply times e to the x. Like so. And again, on the left-hand side, I have e to the x y prime equals minus e to the x. Integrating both sides now gives me e to the x y is equal to minus e to the x plus c. That's another constant, so I'll call it c2. Finally, y then is e to the minus, e to is minus 1, if I multiply times c to the minus x, plus c2 e to the minus x. Now here comes the interesting part in this type of problem, and it is finding c2. So to find c2, the thing is that we don't have an initial condition, because this is when y is 0, it is 1, but now x's are bigger than 2, so I cannot apply y of 0 equals 1. Instead, what I'm going to do is I'm going to make sure that these two functions are the same at the value where there's a jump, which is the value 2. So y of 2, in this case, let's call this y1, let's call this y2. y1 at 2, well, it's 1 because it's a constant function. y2 at 2 is negative 1 plus c2 e to the minus 2. And I want these two to be equal, so then that means that minus 1 plus c2 e to the minus 2 needs to be equal to 1, or c2 is equal to 2 e squared. Finally, our solution then is y1 and y2, which is going to be 1 from 0 to 2, and minus 1 plus 2 e squared e to the minus 2. That is e to the minus x, and this is our solution.